I want to take a moment and talk about solving inequalities that result in a negative x towards the last step. They create a special situation for us where we need to take an additional step that we don't need to do when we're solving equations that end in a negative x towards the last step. So let's start by taking a look at an inequality that might end in a negative x. A good example for that might be 1 subtract x is less than or equal to 6. And just like everything we've done before, we solve it like we would solve a regular equation. So we're going to start by subtracting 1 from both sides. 1 subtract 1 is nothing. This negative sign is still there, so it needs to come down, and I would end up with negative x. I keep the same inequality symbol, is less than or equal to 5. So I'm ending with an inequality where I've got a negative x. Now, in a normal equation, our next step would be to divide by negative 1 or multiply both sides by negative 1, and I would end with a regular x. Well, before we do that, let's look at this a little bit differently. There's some different math that we can do that still results in a positive x. I think something's going to happen, and it'll show us why we need to take special care at this point. So right now I've got negative x, or the opposite of x, is less than or equal to 5. So we talked about one way to get this to be positive is to multiply or divide both sides by negative 1. Another option I have for getting or ending with a positive x is simply to add x to both sides. So I'm going to do that. I'm going to add x to both sides. And I get nothing is less than or equal to 5 plus x. So I've got my x values positive now, but now I have x values and my numbers on the same side, and I know that when I work with equations I don't want that. So I'm going to subtract 5 from both sides, and I get negative 5 is less than or equal to x. Now, I could have gone straight there and it would have been easier to divide or multiply this side by negative, but something happens with this inequality symbol that we need to take into account. So let's look at this again. I've got negative 5 is less than or equal to x. Another way of thinking about that is if negative 5 is smaller than x, that really means x is bigger than or equal to negative 5. These two things say the same thing. They're really both saying that x is bigger than or equal to negative 5. And I know this is true because up here the inequality symbol points from the x to the negative 5, and down here the inequality symbol still points from the x to the negative 5. Well, let's look at what happens over here when I divide by a negative value. So let's say I wanted my next step here to be divide by negative 1. Divide by negative 1. Well, I get my x, and I get my negative 5, just like I got over here. But look at the inequality symbol. It's pointing the wrong way. Here, it's a less than or equal to symbol. Well, I know when I attacked this problem a different way, I ended with a greater than or equal to symbol. So mathematicians had to create a special rule to deal with this case. And here's the rule, because one of the things we want to avoid is we want to avoid having to go through all this extra work to end up with the correct solution and the inequality pointing the correct way. So mathematicians came up with this rule. And the rule simply is, if you multiply or divide an inequality by a negative value, you must flip the inequality symbol. So in my example here, I divided both sides of my inequality by negative 1. According to this rule, I must flip the inequality symbol. Here, it was less than or equal to. When I flip it, my new inequality symbol ends up being greater than or equal to, which matches the answer I got going the long way around. So one last time, if you multiply or divide an inequality by a negative value, you must flip the inequality symbol in order to reach the correct solution.